Coming up on this episode of the IoT Inc. Business Show.
And that's why I kind of get to this notion of it being more than a simulation. It's also a collection of behaviors, which are defined as services that can go and orchestrate actions across these business systems, across other digital twins, other physical objects. And so it's that ability to orchestrate in addition to performing the simulation, where you start having the capabilities to have transformative outcomes.
The IoT platform is generally thought of as networking tech, middleware to connect all the IoT components together, and often it is. But a certain class of platforms, the so-called application enablement platforms, or AEPs, also provide the development and execution environment for the digital twin. In this episode of the IoT Business Show, the third in a series on the digital twin, I speak with Jason Schern and Jeff Miller about the DT and its relationship to the AEP.
All this and more on this episode of the IoT Inc. Business Show. The people, the business, and the technology of the next generation internet. This is the IoT Inc. Business Show. And now, here's your host, Bruce Sinclair.
Hello and welcome to the IoT Inc. Business Show. This show is made possible by sales of my book, IoT Inc., published by McGraw-Hill, and the IoT Inc. Certified IoT Professional, or ICIP, online training and certification program. Become a certified IoT professional by completing the program's 3 courses: ICIP Technology, ICIP Business, and ICIP Strategy and Digital Transformation. Details of which can be found at www.iot-inc.com. That's www.iot-inc.com. With me today in the IoT show are Jason Schern and Jeff Miller of PTC. Jason is Senior Vice President of the IoT Platform Practice in Customer Success, and Jeff is Vice President of the IoT Transformation Advisory Practice. Combined, they have over 45 years of experience. Gentlemen, welcome to the show.
Hey, thank you.
Thanks, Bruce. Glad to be here.
Now, I go back a little ways in CAD, and I knew PTC first as Parametric Technologies. And so, for our listeners, that was actually a new type of model, and the company named themselves after it. So it's kind of. How long have you guys been with the company?
I've been with the company since '98. So I actually joined the company right after we acquired computer vision, and our dominant products at the time were still the CAD solutions.
And it was called Parametric Technologies?
Absolutely, yep, with the old logo and everything. And it changed to PTC a few years after I joined the company.
I joined back in 2011, and I was attracted to PTC because at the time they were being very acquisitive and were building out the next generation of PLM, and that's what brought me into the company.
Well, now, look at your titles, because both titles wouldn't have been around 5 years ago, and in my view, they're very strategic. So, in particular, of the IoT platform practice and in customer success. So maybe you just give us a little bit of background on yourself and your experience in IoT, but in particular, I'm interested in I'm also in customer success part, if you can explain that to the audience.
Sure. So most software companies have always had a professional services group, and as companies have moved towards subscription-based business models, you've reached a paradigm where getting customers to first value very quickly becomes increasingly important. And in order to do that, you need both professional services, education, support services, customer success management. You need a group of teams working together in a very aligned fashion to help customers get to first value quickly and then be able to, then progress on to recurring value, et cetera. And so within PTC, we did that. We strategically looked at our organization and said, we can't have professional services and education and support services and all these groups working independently. They actually need to work together to help customers get to value more quickly. And so we brought those groups together under one organization called Customer Success. And so the IoT platform practice within Customer Success is a group of IoT professionals who are really focused on our IoT platform to help customers, systems integrators, or independent software vendors very quickly be able to use our platform to build IoT solutions.
Okay, and yeah, I mean that's an interesting note. Just to key off of it, what's in saying is getting customers up to speed really fast. So that's part of it. But also you have to keep them successful, because when you do go to a subscription model, or maybe eventually to more income-based model, you have to keep them your customer, right? Because they can leave. So you need to continuously keep them successful, because every 12 months. What is the cycle for yours? Is it a 12-month cycle or longer?
No, I would say back in the PLM days, you'd have these longer deployments that would go half a year to a year. But in the IoT space, it's a much more agile approach to building solutions. So our engagements with clients are in weeks, and on the long end, months. And they're very iterative that way. So you'll get to first value, and then you'll go on to the next project for recurring value. And so instead of having one big monstrous project, you get to value quickly and then start expanding after that.
And what about the business model, though? In particular, you were mentioning a service model, and so that implies, I'm assuming that implies time, so you're renewed after a certain time period. Is that right? And then if it is, what is that time period?
Well, so the software is typically purchased on a subscription basis, which is renewed regularly. Yeah. And then our services are usually engagement-based.
And how is it renewed, though? That's what I'm just wondering, is like how, really what my question is, you need to be accountable to your customers in a certain frequency, because they could cancel their subscription, as opposed to when in the old model, when they used to buy the software and then maybe have a support contract. You might lose a support contract.
It varies a little bit, but I think it's very typical for subscriptions to be annual based.
Okay. That's what I was wondering. Great. Jeff, why don't you give us a little bit of background about yourself, and specifically now, and again, I'm also interested in the transformation advisory practice. Again, that's something that is true, strategic, and it wouldn't necessarily have been around, let's say 5 or more.
You're right, Bruce. Yeah, at least not in this form. I'm a mechanical engineer by education, and began my career in the nuclear fuels business, commercial nuclear energy industry, designing reactor systems and fuel systems. And back then, the digital twins of that time, 25 years ago, of course, we didn't call them digital twins or software-defined products. They were computer models that simulated one or two critical operating parameters. So I did that for a number of years, and then moved into value chain, manufacturing and product-oriented value chain. And I mention that here because that's really informed my view of how to get value out of IoT, and specifically the role of the digital twin or the software-defined product. The practice that I lead came up as a consequence, really, of our first Harvard Business Review article that our chief executive officer, Jim Heppelman, co-authored. And what we found, this is about a year ago, was that companies were asking, not so much, well, what's IoT? People knew that, but they were asking, where do we start? This is different from ERP. This is different from cost-based enterprise solutions, which CAD and PLM fall into. So we found that there was a moment in time where customers were asking, and prospects were asking, how do we embrace this? How do we weave it into our business fabric? So with that in mind, we built this practice. It's not digital strategy per se. We don't compete with those firms that are out there helping customers figure out how to fundamentally change their EPS models through digital technology. No, we're the pragmatists. As Jason said, we work very closely, our two practices. We're the ones that help put together the business strategies and the use cases that'll leverage the unique capabilities that are made possible by these powerful new technologies and platforms. So it's kind of a unique space, and as Jason said, it's a bit unusual for a professional services practice of this type to reside inside a software product company. But again, what we're finding is that customers are very hungry for this kind of advice and counsel, so they can maximize the value of these investments they're making in these powerful new tools.
Yeah, and I think you bring up a good point, and that's kind of what I took from from your title on IoT transformation advisory, because in my view, and I think PTC shares, is that to really get the full value out of your IoT product, your service, your solution, you need to change your company. I mean, every single department in the company, starting with sales, which is why we're talking a little bit about this customer success. But there's an example of where the organization, if they did take your technology, for example, customers put it into a discrete product, sold it, then, well, all of a sudden, if you want to get the most out of it, your engineering has to look at data. Your salespeople need to be more consultative. They're going in there trying to make them successful because there is this renewal process. Support needs to look at the. I mean, it really changes the company into a data-driven organization, and I think that's the real digital transition myself. But I'm biased. So are those the type of conversations?
Oh yeah,
you're having?
Absolutely. In fact, a few years ago, the term disruptive technology became fashionable on the scene. And in hindsight, you look at the technologies to which that term was applied, they pale in comparison to the impact, as you say, Bruce, that IoT has. This is like the ultimate disruptive technology. And not in a fear-generating or negative sense. Heck no. In a very positive and opportunistic sense. We've been trying to do things like data collection and predictive analytics for years and have struggled to do so. We've had computational fluid dynamics, and we've created skinned wireframe models, and we all remember those heat maps from Nastran, finite element models, et cetera, et cetera. Those were all existed, but the ability to integrate them into the flow of business and to use those capabilities, only now, I think, are we seeing the cost and return on investment factors really line up very positively. So that's why I look at IoT as the ultimate disruptor, even if some of the core things that it does are things we've been seeking to do and have been doing manually for many years.
And the digital twin enables all those things that Jeff just outlined right now. Without that digital twin, you can't pull all those things together in a scalable way.
Brother, I agree with that one. Well, let's get into it a little bit, and I think Jeff has kind of opened it up, Jason, I think as well. But let's talk about models and really talk about the differences in an IoT model or digital twin or a software-defined the model within a software-defined product. So we've had a couple that I brought up the geometric model. Jeff's brought up the FEM, the finite element analysis modeling. We've talked about skinning wireframe diagrams. All really physically based models in the sense of what does it look like, how does it move, where is it, right? I mean, well, maybe expand on what you're, and Jason, I'll start with you, but what do you see as being the difference between the models, because you've been with PTC for a while, the models that we're dealing with now in IoT versus the models that we were dealing, I was relatively in the CAD business as well years ago, that we were dealing back then? Sure.
I think a couple fundamental differences tie back to the fidelity of that model. So all of those things we talked about, a digital model, a digital twin, and I'll just use that term for simplicity, but a digital twin is more than a simulation, because the digital twin itself is an entity that can be lifecycle managed along with its physical counterpart. So as you mentioned, it represents digitally the physical product, the physical object, and the digital representation that can be used to perform simulations. So it includes things like geometry. It includes things like bill of materials that define the physics and the physical aspects of an object. But it also typically includes other aspects like the software characteristics, the sensors, and the related business systems that help define the behavior. And so when you can tie those together and link them to the actual physical product where you're getting that sensor data back, the fidelity of that digital twin now reaches a level that it enables simulations that you could never do before or you could never do in real time.
Yeah, no, I like that. Jeff, what do you think?
I agree with Jason completely. It's a subtlety perhaps, but we're almost anthropomorphizing. We're turning the digital twin into an almost a living entity. I see this trajectory continuing where the asset in the field squawks, talks about itself, feeds data back to the design engineer, feeds information to the service process. We almost imbue it with the ability to have a speaking role in the continuum of business. That, to me, is the fundamental difference between any of the old CAD models that we would apply modeling to and where we are today. And it encompasses exactly what Jason talked about. It's a model that will take the data from an instrumented physical model. It'll talk back to the design engineers. It has the predictive analytic capabilities attached to it. So I think the focal point in commerce is going to move from people and roles to the role of the digital twin. I think you'll see much greater levels of automation of processes. We're seeing this today with our customers. It's slow to be adopted, but it's coming. We're seeing it with the advent of strong predictive analytics tools and the advent of better networking communications for assets that are in the field and better edge computing. All of these factors, if you take the chain from the physical asset back to the digital twin model, those links are strengthening. The data that flows through them are strengthening and becoming more robust. And I think that makes the digital twin become a more powerful entity in and of itself in the language of the business continuum. That's what we see as being exciting.
Yeah, no, that is exciting. And I think just to maybe close the loop around both of what you were saying, I agree. I think from a fidelity point of view, that's exactly correct. And it may not be in the traditional sense of fidelity, although it could be, but it's just the multidimensional fidelity where you're looking at far more things than just geometry. And secondly, that's kind of how I describe it. I like living entity. I call it a living model. And when people ask me, what's the difference between previous models? It's a living model. And the reason it's a living model is because, as you were talking about, Jeff, it is connected up to sensors, but it's also connected to internal data sources. They don't have to be internal sensors. It could be other things. But more the point is, it is living. If done correctly, it is pulling the data from these data, updating the model, improving the model, using the, and I kind of, I don't know, at a 50,000 foot level, that's how I kind of see the difference. But I like, adding in the fidelity because I'm looking at more things. Anything more to add to that, or does that make sense?
Oh, it does. And as you talked, it reminded me of an example that I saw recently with a university we've been working with in Israel. And they took a robot, an anthropomorphic type robot like the Honda robot or something else, but a small scale, something that fits on a tabletop. And they wanted to be able to teach this robot how to do a task. So not program it to do the task, but have the robot learn on its own how to do it. And the simplified task was simply a weightlifting type scenario where the robot would crouch down, grab an object of variable weight, and then be able to stand up without falling over. Right? And you can imagine that each different weight is going to require different actuations to the gears and motors and able to keep that center of gravity within the envelope to not tip over. And so they did this. So they built it, and they built the model so that through trial and error, the robot would learn, it would pick something up and fall over and then learn from that and be able to stand up successfully the next time. Well, they wanted to then extend this learning concept back into the digital twin by creating a digital twin and tying that digital twin to the physical robot. Now they're able to take that sensor information from those failed attempts, feed it back into the digital twin and the design tools to then calculate what the next attempt should be. And then they realize, well, this digital twin is of a level of fidelity that we could just run a whole bunch of simulations in the digital twin itself to learn all the different scenarios for all the different weights and then download it to the robot. And now the robot's just instantly smart and can figure out any weight. And it sort of reminded me of the Matrix scenario, right, of learning to fly a helicopter by downloading it. And that's what the robot did, right? The robot did not know how to lift weights. They went into the digital twin, taught the digital twin how to lift any size weight, and then took that learning and pushed it back out to the physical world. And now this robot knows how to do that task. And that can be done it's not quite real time, but in near real time. It can happen very quickly. And that's when you start tying that physical object back to the digital twin in that truly integrated method, and the possibilities are unbelievable.
So building on that for just a second to show the centrality of this digital twin, take that example that Jason gave about the ability for a device to learn and alter its operating parameters, and take those same learnings and those same data and now bring them back through the digital twin to design. Truly, how far are we away from generative design, truly generative product engineering, using exactly the same knowledge that Jason's example gained through trial and error? Well, if you set a design envelope for certain actuators or certain runs of travel or certain RPMs or whatever the parameter may be, the design engineer sets an envelope and then says, you know what, I'm going to allow field experience and feedback from through the digital twin to influence the next configuration or the next set of manufacturing parameters. How far away truly is that? I think it's very close, using exactly what Jason's example bore out. That's the power of the digital twin.
Yeah, no, there are lots of examples that way, and I think for everyone listening, we want to be clear that there is not a digital twin. In each product, let's say we're a discrete product, there's going to be many. And we've just talked about a few of them, and Jeff, the ones that you're talking about are being used, in the sense usability models and utility models, and developing that digital. I keep on going. I don't like digital twin. I'm going to say it, and I have said that before. We're using it because I think it's a common denominator between our different languages. But more what we're talking about here is models and a simulation. So doing the modeling, you model how you think your product's going to be used. You model how you think your product in the ways that your product's going to be used for, what they're going to be using it for, and then you look at the delta. And this is an example. And the one another example that Jason was bringing up. And I kind of like thinking about it going forward and backward in time. When you have a digital representation, and we're going to get into all the benefits of that, although we're already nodding quite feverishly to each other here. But you can go back and you can analyze what happened, or you can go forward, in the Jason was saying, and say, well, what if we did this, and then kind of learn from that and download it, matrix style into the object. So. Point number one is feel free, obviously, to disagree with this, but number one is this is not a huge twin. And then when we talk about a digital, really what we're talking about, well, let me just add to you guys. So what's your definition? Jason, let's start with you. What is a digital twin? Use whatever terminology makes sense for you and the PTC verbiage.
Sure. So, digital twin has its weaknesses as a term, but I think one of the reasons it's gaining some traction is because, to your point, there are many models that can form a subset of that digital twin. But it's the combination of all of those models that get managed together as an entity. And so you think about the life cycle managing a physical product, you're going to life cycle manage the digital twin entity along with that physical object so that they remain in sync. And that digital twin entity will evolve over time as new models and new capabilities are added to it. So as sensors are added, you have new information. As new modeling techniques are added, you have new capabilities for simulation. And so the digital twin is not just a model or a simulation. It's really the full collection of everything that you have available to digitally define that physical object that then allows you to drive those simulations.
I think implicit in what Jason just said, Bruce, is a really important thing for our listeners to recognize, that when you say digital twin, you generally think of a computer-based representation of the physical product, a picture, a 3D model, with nice reflective surfacing.
Yeah, that's my issue.
And what Jason just said goes much beyond that. The digital twin, certainly for AR purposes and VR, you think of it as a digital presentation of that physical product. But it's the connection of all of these other pieces of data to execute a set of business functions or engineering functions or manufacturing functions that, again, may have been around piecemeal for years, but now is brought together in the form of the digital twin. So it's much more than the visible, seeable item itself, as Jason said.
Yeah, no, I agree. And really, my opinions, and the reason we're doing a series of podcasts on the subject is I believe the digital twin, the software-defined product, is the most important technology in IoT, because what it's really doing in a high-level sense is we're virtualizing the physical. And like we've both been talking, or like we've all been talking and doing that for a while, but now we're virtualizing it we're virtualizing it and we can realize other types of advantages from it. So the phenomena of physics is you could apply it to biology, you can apply it to economics, you can apply it to financial, you can apply it to crowd control, right? So it's not limited now to just a physical representation of where, location, first derivative, second derivative, and that's pretty much, covers most of the stuff that's happened in the past. So the virtualization of it allows you to then simulate, go forward and path, but it allows you also now, and we've been talking about this in different ways, but it allows you to connect it to the internet as if it was software. So now you've got something that integrates into, directly into the internet, and then wow. This is, one of the spiels that I have, and I do it more just to try to set a mindset, is I just differentiate the smart connected product from the IoT product. And the reason I do that is just using the internet as a plumbing, just for connectivity, is so not using the internet, if you know what I mean. And so, companies like PTC are on the forefront of the digital twin technology. And by having that digital representation, it allows you to take full advantage of the internet. Any thoughts on that, guys?
Yeah, I'll jump in here. I agree, could not agree more, that this is a confluence of connectivity or networking technology via the internet, and by the way, low energy Bluetooth and cost effective fifth generation communication, fifth generation LTE, all these technologies that allow us to actually connect to the devices. Companies that want to produce what they call a smart product are realizing that they got to have the plumbing, they have to have the connectedness to a digital twin, and all these things kind of stack up in addition to having a platform upon which to build applications. All those are kind of the ingredients. And again, to me, this is a confluence. Everything came together in this time, in these last couple of years, with the ubiquitousness of the internet, the growing strength in communication capability. So now companies can actually put some wood behind the arrow when they say we have a smart connected product, or we have smart cities. Everything is going to get smart. It's going to be the new buzzword. Everything will be smart. But to enable that requires exactly what you've said here. Can't do it without that.
Is that virtualization?
I mean, by comparison, to go back in time, 25 years ago, we would pull data off of a turbine generator at a power plant. We'd pull it off sensors, and we'd write it to analog data to tape, and then we'd use a modem to connect it and send it back to headquarters 1,000 miles away. That technically was Internet of Things. We sure as heck didn't call it that. So, and it was impractical to try to do very much with it. But so the ideas have been around, and now they're enabled with these three pieces.
Well, let's dissect this a little bit. We've been talking about some of the uses now, and I'm going to want to circle back to that in a minute. But just to be clear from a technical point of view, what do you see a digital twin? I mean, I'm looking at it from a simplistic point of view is models, but let's just say model, and then place model within a simulation environment. How do you guys? What do you think? Is that accurate, or do you have maybe a clearer way of describing it?
No, I think that's accurate, but I would extend it a little bit to include, when you look at the digital twin, we discussed it's a collection of models. They could be geometry-based models, they could be analytics-based models, etc. As you mentioned, even economic-based models and others. It's a collection of those models around a common data model and meta definition of the physical object. Now, I would argue that the digital twin is also informed not just by sensors from the device, but from all of these rich resources you can get through connectivity to the internet and other business systems, whether it's PLM systems or ERP systems or even weather forecasting, et cetera. And it's that federated collection of information that makes up the complete instantiated definition of a digital twin. So in addition to being a collection of those models, the digital twin kind of becomes the locus of federation for all of those different resources. So if I want to get to those data sources, I get to them through the digital twin. So if I need sensor data, I get to it through the digital twin. If I am the physical object and I need geometry information, I get to that geometry information through the digital twin. So for example, a physical object can have physical sensors, but you can also have virtual sensors. Like the example I provided earlier, center of gravity is not a physical sensor. It's something that has to be calculated in real time based on the current geometry and position of the object. And so through the digital twin, I have access to the systems that can calculate almost in real time my center of gravity and provide that back to the physical object, again, through the digital twin, that allows me to make decisions in real time based on that sensor information. So it becomes the locus of federation between the physical world, the digital world, and all those other business systems that are informing the digital twin.
Yeah, I like the term informing, and absolutely. So, an IoT product at its core, how you create value product is you collect data and you transform it into useful information. And that data, like you said, just have to come from its internal sensors. They come from external sources as well. But I'll add one more, and this is going to add a bit of a hierarchy to it, and I'll ask you what you think. But if we're talking about collecting data from different data sources, we're on the internet, we're maybe collecting temperature data, maybe we're into our business systems. But guess what? We can also connect up to other digital twins and other products. And when we can connect up to other products, right, that's when we can start orchestrating together, and then we start the word which we haven't mentioned yet, which is outcomes, and being able to orchestrate these products hierarchically in a way that delivers an outcome. So, Jeff, what are your thoughts? Is this something that you're selling right now to your customer? Outcomes? Is it still too far out there? Just give me your
not at all. No, we certainly are. We're focused on outcomes. Many of them are at one level of hierarchy of scale, kind of direct. But the example that you give is actually one that appeared very prominently in the HBR article about smart agriculture and smart farming, and Jason kind of made a glancing reference to it, talking about weather data. You can take a tractor and instrument the tractor, and then you can take the data from the tractor and incorporate that with harvester data and then performance per acre data and watering data, and you can create basically systems of systems. And so not only can you drive outcomes at individual assets, many of our examples, crawl, walk, run, are examples of doing that with single assets. But the true power, and I would argue probably geometric power in outcomes, is doing exactly this for systems of systems. And this, to me, also drives to one other point. This is where my interest and what I work with our customers on, it makes a shift. Now you're talking about enabling new business models. Smart agriculture 5 years ago was not defined by adjusting fertilizer application rates based on last year's harvest. That was really hard to do. Now that's almost table stakes, just as a specific example. But again, that happens because of exactly the integration across multiple layers and tiers of integrated systems that you described. So we make new business capabilities possible to make new outcomes possible that previously were not economically viable. That's what this is about now.
Yeah, no, I agree. Jason, anything else to add to the outcome now, the split outcome into the conversation?
No, I think Jeff covered it, and you highlighted a very important point, which is digital twins become an information source for other digital twins, and they really start informing each other. So whether it's like objects in a fleet whose collective information is informing the entire fleet, or it's other physical objects that work in conjunction with each other that can inform the behavior of the others. I mean, when I talk about the digital twin being a locus of federation, it's not just a locus of federation for sensor data or the digital product definition, but it's for these business systems, other digital twins, third-party information sources that when combined together meet a specific outcome that you've designed for your solution.
Yeah, and that's really what's driving the digital twins is going to be a particular outcome, and like Jeff was saying, it could be on an individual asset, and that's fine, and that's generally where we are today, and that's why I was asking, if there's any customers that you're dealing with that go up one more level where you're multiple products to work together. But today we are in a sense using IoT as IT and operational efficiency. Asset utilization. This is more in the term of predictive maintenance. So people talk about predictive maintenance, operational efficiency, but guess what? That's what we've been doing with IT, and that's okay. You know, that's a good thin edge of the wedge to get into it. But now what we're talking about, and that came up, that we can start creating new business and start looking at the top of the P&L where we can grow revenue with new products or innovative products, right? And so we're there, and that's why I was just taking the pulse from you guys as to where the customers are. I don't think we're fully there yet. I have seen it. But this, just to give our listeners, this in my view, and you guys correct me but in my view, this is when you really, and you said geometric, and that this is when you start really creating value. But we need to get one step at a time. Mm-hmm. Jason, have you seen this? Have you seen from your dealings with customers?
I have, and to your point, it's not that true outcome based driving new business models is not broadly realized today. It's being realized in patches with clients who are a bit more mature and have been working at this for a little bit longer than others. But I would argue that the pace of change and the rate at which customers that we work with are progressing towards these business model transformations is increasing very rapidly. So we used to, maybe a year and a half ago, it's those very, operational efficiency type discussions, and they've moved beyond that. And now and I think Jeff can attest to that, he just spent a couple of weeks with a very large company in Asia having these very same conversations, and they're not looking at operational efficiencies. They're having conversations about how they actually build new revenue streams through new products and solutions.
Yeah, exactly. I'd like to share an example, if I could, Bruce, that may draw us a little bit away from the geometry paradigm. We recently did a piece of work with one of the large airframe manufacturers, global airframe manufacturers. And so for them, one aspect of smart connected is to make sure airplanes keep flying. So they decided to instrument the galleys, to create a smart galley, and they decided to instrument ovens. So here's the scenario. Now I instrument the oven, and the oven decides that it's going to take a little bit longer to heat up. And we've got predictive histories and predictive analytics. So some envelope of acceptable warm-up time is exceeded. Now that oven is predicted to fail at a certain point. Automatically, without any human intervention, and this uses a lot of different companies' products, a lot of different supply chain players in this digital twin. The digital twin of the oven is known and now has to be replaced. So the alert goes out, and they begin to plan where will the airplane be, where is their inventory of a replacement oven, where is their labor. Labor's part of the digital twin, the labor to maintain or replace. So to cut to the chase, the business case that they settled on, that they're now building a solution around with their airline customers and with third-party aircraft maintainers, is that as soon as an alert comes out, and again, the example is an oven, an alert comes out with a predicted failure, automatically, almost without any intervention, the next logical available time when that airplane is at an airport with an oven, with labor, or a part can be moved, it'll be scheduled for replacement, minimizing the downtime of the aircraft. All made possible because of this federated model of a lot of dissimilar systems of data, parts systems, labor systems, aircraft scheduling systems. It goes to Jason's point about the digital twin being that locus and that focus point. And this is a real example. And they're selling this capability to their airline customers, and many other examples. I chose an oven, but you can apply this to any other aircraft system that would be a no-go item.
Yeah, and it's kind of funny because the oven, it's needed. But yeah, no, that's a great example, and it is an example of using digital twin to look into the future, and in this case, predictive maintenance and just predicting when something to go wrong. But let's share here, guys. And for me, I talk through two sides of my mouth when it comes to platform. On one side, there's no value there; it's plumbing. And eventually that's going to commoditize. On the other side, if I say, well, however, if you are developing a digital twin, there needs to be an environment to do that modeling for the digital twin. There needs to be an environment to execute that digital twin, and that's going to be that simulation environment that we were talking about a little earlier. So what I want to know from you guys, and Jason, maybe you can take the first crack at it, is how is digital twin, take us through the steps, and it doesn't have to be super low level, but what are the steps to create a digital twin within your platform?
Well, a little bit of it depends on where you're starting in terms of the fidelity that you're going for. But I would say that for higher fidelity digital twin models, it actually starts in the product development and design. So in the CAD tools where you design for the sensors.
Okay.
So Creo today has the capability where you can design those sensors into the solution, not just their geometric shape, but their location, the type of data that they're going to generate. And when that's then published into our PLM environment, it will publish those models into our IoT platform to start building the definition of the digital twin. So in addition to the geometry, I also have information about the sensors, the type of data that are going to come from those sensors. And so now my digital twin definition in my IoT platform is connected to the design. And so as that design is iterated, the digital twin definition is iterated along with it to stay connected. And then we can start building on that model to define services and behaviors that map to the physical objects behaviors, and then start connecting to the actual sensors for physical objects, connecting to disparate systems. And so that digital twin definition gets built up within the platform through those different sources.
Let's use Jeff's example of the oven, and so I'm with you on the geometry, but I want to go past the geometry. Let's say it's going to be in the case of predictive. Let's say it's a predictive maintenance type situation. So we need to the model of the oven, and as Jeff was mentioning, there's an envelope there of heating time, and so that's pretty simple. So if it's an envelope, then maybe we can make some predictions. So who wants to take me through that process? So the geometry one, I think most people are pretty familiar with. What people are less familiar with, and this is a core competency that your customers, many of the listeners of this show, have to develop, is going to be more on the data science side of things. And so let's talk a little bit about that. How would we go about using the tools?
In addition to defining the sensors for the oven and the type of information that's going to come from the sensors, you can now use that information to do anomaly detection. So you can build your analytics model into the digital twin using something we call ThingWatcher that is basically going to learn what normal operation of the oven looks like, and then through machine learning be able to identify when there's an anomaly. And then you would define a service in that digital twin model inside the platform that would integrate to a service parts management solution to be able to query when what location has those ovens available and has labor available to be able to retrofit it. And so you start building these services up to query these systems, gather information, and pull that back into the overall behavior that you're trying to define for the digital twin. And so when you're done, the digital twin is not only reading the sensors, understanding when that sensor is out of compliance, it now has the services defined to be able to go pull information from your service parts management solution to understand what location has those ovens and the labor available to be able to schedule the retrofit. So those other pieces get defined as services within the digital definition in the Thing model.
Okay. So I think at a high level saying is that you are collecting the data, and you're using that collection of that to create the initial instantiation.
Yes.
In this case, how it heats up, and then once you have that model to some level, and it could be at the very beginning, and maybe it won't be that accurate at the beginning, but over time it's going to get more accurate. Then you interrogate that model, and that's kind of the simulation part. You interrogate the model with the simulation and say, well, what if? What's going on here? Are we within these tolerances? And if we're not, then what's the chain? What's the logic that goes from there? Is that? It
is, and the additional piece to that is you're not just defining the definition of the information that's available and the analytics that can be performed. You're also defining the services that digital twin can perform. Those services,
nice.
Those services are most typically activities to go reach out to other systems to gather more information, bring it back, and then make a decision. And that's that orchestration piece that we touched on lightly earlier. The digital twin includes the services definitions that allow you to orchestrate actions across that federated group of systems that inform the digital twin.
Yeah, no, I like that. And, for example, then, hook into your business system or your ERP or your PLM. But
and that's,
that makes a lot of sense.
And that's why I kind of get to this notion of it being more than a simulation, more than a collection of. It's also a collection of behaviors, which are defined as services that can go and orchestrate actions across these business systems, across other digital twins, other physical objects. And so it's that ability to orchestrate in addition to performing the simulation where you start having the capabilities to have transformative outcomes.
It goes without saying that the consistency of action that comes from that, the repeatability, is valuable in and of itself.
Yeah, no, it is. And I'm going to try to dissect this in a more general way for people to understand. But now when you're talking about these services of action, I like that. I like that a lot. But let's break this apart, because from my point of view, we've been talking about three things here. We've been talking about the data, we've been talking about the model, we've been talking about the simulation, and now we're thinking about some actions. So I say data, model, simulation, and application code. I mean, application code that's going to be doing based on the results of interrogating or running the simulation. Now, what I'm interested in, and this in my view is important when looking at different platforms and comparing them. First of all, if the platform you're looking at does not have this concept, and I'm going to dig into a little bit more what I mean by that, and I mean the concept of digital twin and having it separated, and I want to dig further into that with you guys, don't consider the platform. And that's my point of view. Obviously, this platform does. So that's why I definitely I was excited to have you guys on the show. But that's my first advice. Though I want to go a little bit further. When you're looking at your platforms, in my view, this combination of, let's put data aside, but this combination of model, simulation, and application, how that's executed and run. Now we're talking about the platform, but we're saying now we're going to use a discrete product instead of like a process or an environment or something like that. But let's say it's a discrete product. We now need to put that functionality into, let's say, that tractor, or no, into the plane. Let's say we're plane. So my question is, for you guys, is how separate is this? Because I believe over time, these models are going to become intellectual property, very important intellectual property for the companies that are developing them. And if you do buy into that, then what that means is these models should be discrete in the sense. In some platforms, this is a big old jump code where you've got the code for modeling, you've got the code for the simulation and the application, all kind of just one big ball of code doing it all. And that could be like a push button, and that might be good for certain applications, but I think over time it's really important to be able to reuse these models. It's really important to have them some sort of a standard way of representing them. Give me your thoughts and maybe just explain to me, we'll start with you, Jason, but how are these different pieces, model, simulation, application, how are they packaged, and how do you actually then put them into the product that you're
Sure. Well, I mean, platforms typically want to pull all of those together because there's tremendous value, especially in terms of being able to build things rapidly when they're integrated by design. Now that
yeah, and what I mean though is they can work. Of course, they have to work together. The question is, when you're now putting it in, can you save that model and then use it for another purpose, or is it just all together? If you know what I mean. And we're getting down to the code that's going to be run wherever it's going to be running, in the cloud, on the edge, in the fog, whatever, for this product. So that's kind of more.
Sure. It's difficult for me to envision true portability of individual pieces of that, but what is easier for me to visualize, and it's what a lot of our customers do today, is just because all of that is integrated into one model and one platform does not mean that other platforms can't use that information in an integral way. And so if you think about, just look at our platform today. We have the ability to work with different device cloud providers. We have the ability to work with Predix, for example, and for Predix to work with us. It's not so much of taking that overall digital twin and breaking up the pieces to distribute them in other places. It's making sure that those digital twin components that you want to be able to leverage are accessible to you and you can use them. And so our focus is more about making sure that the digital twin definition is accessible, not just with our platform, but through other platforms as well. So, I buy that. So you're kind of saying then, let's just use the example of another platform then. How would a Predix system use a digital twin developed in yours, or is that possible? So the digital twin definition that we have, can be queried through other systems, through various mechanisms, REST APIs or other things. And so if there's a Predix model that needs to use information that's defined in ThingWorx, it's absolutely queryable, and they can pull that information and use that within Predix.
Okay. And so when we dig down a level, what you're saying, and that's fine. You're saying is that the two platforms can together, and in one of the ways they can communicate with each other is to access digital twin from one, or right, and as opposed to necessarily, holding it in your hand.
The digital twin model itself is not just uniquely portable, but the aspects of the digital twin that are of interest to you that you need to use absolutely are available.
It's accessible. That's correct. What you're saying then. Yeah. Okay. Jeff, anything you want to add to that before?
Only that in the same way it's accessible, the systems have to be able to place information to, for example, in the oven case, send a scheduling signal, send a parts ordering signal. So there's outbound and inbound, so to speak, integrations that I think are critical here.
Yeah, no, from a communication point of view, absolutely. And talking about the definition of the platform. So I want to wrap this up with a couple quick questions. And that is, give me the relationship, or describe the relationship between digital twin and the platform, the digital twin and the analytics, and the digital application. Jeff, do you want to give a?
I'll start from as the business consultant from the app and go backwards, and then toss to Jason. The digital twin to the app, I think you're going to see more and more digital twins. And again, we've moved off of geometry throughout this conversation. We'll see purpose-built digital twins where much of the rule set and the actions are bespoke. Those will be unique IP in the same way that the geometry itself, the CAD models, are unique IP. And we're starting to see that now. Jason made reference to this large Asian industrial that we're doing some work with. They've got a very specific perspective on what they want their digital twin to be able to support from an application standpoint, which means from a business rules and action standpoint. So we began with the idea of a physical model. That's where we've anchored our thinking about DTs, digital twins. But I think it's going to grow, and we're already seeing demand now for different forms of digital twin driven by business requirements. So it's no longer a push, it's now a pull.
And then clarify a little bit, the relationship between the DT and the application is going to be done by a series of queries. Maybe expand on that. Is that what you're referring to?
It can be in part. I think the structure of the digital twin will be dictated by the applications we want to run. If we, for example, the true value of the digital twin is in prediction, not so much in integrating geometry because we're going to change the physical aspects of the model, but more in terms of operating parameters and serviceability, then that'll drive the form and structure of the digital twin, because the applications, the business applications that we want to run are set in a certain way. So
interface to it is what you're saying. Kind of the interface to the digital twin will be defined by, in the other case, the requirements of the
exactly.
Right? Yeah. Okay. Analytics.
I'll go to Jason for analytics and the platform integration. Let him cover those.
No problem. So Bruce, I'll do the same. I'll start with the application side. If you use a sort of object-oriented development paradigm, the digital twin definition essentially becomes the class model that you use to instantiate digital twin instances in your overall IoT solution. And so from an application standpoint, the digital twin is that class definition that you can then instantiate and use that digital twin instance as part of your overall IoT solution.
And so is there code that does your platform then generate an executable that can then be incorporated in, let's say, the oven or the airplane? Is that how you would use it?
Well, it depends on how you ended up deploying it to the physical object, but it would either deploy as an executable or as something that you access via the cloud, and a lot of times it's accessed via the cloud. Okay. And then from an analytics standpoint, the digital twin provides that base data model that you would use for automated ingestion into machine learning and analytics tools for things like anomaly detection and predictive analytics. And that digital twin can also be used to perform physics-driven simulations and design tools. So from an analytics standpoint, the digital twin becomes that base consistent data model that allows you to very easily ingest the information in for the machine learning analytics and for the simulation activities.
Absolutely. It's the basis for it. Okay.
And then from the platform standpoint, the platform becomes the solution to define and lifecycle manage that digital twin. So it becomes that locus of federation to increase the fidelity of the digital twin through integrations to other data sources like other systems, other digital twins. And so the platform really becomes you can almost think of the platform as a way to define and lifecycle manage that digital twin that then is used by your applications to instantiate and connect with those physical objects and enable that orchestration that happens across the digital physical boundary.
No, I like that, and it's right. The platform has that very important role, and that's why, to one sense, it's a lot more than just I think we'll leave with that, guys. I think that was very informative. And can you just give our listeners maybe some more information of how they can reach you, how they can reach PTC, or get a little bit more of what we've been talking about with your particular?
Yeah, sure. PTC.com is one of the best sources to go and learn about our solutions, how we look at the world when it comes to IoT. You'll find references to the Harvard Business Review articles that Jeff mentioned, which are actually really wonderful entry points into the philosophical and practical aspects of IoT and how we see the IoT world. And then you'll also see links to recordings from LiveWorks keynotes and other presentations where you can see working examples of the digital twin in action and be able to take what we described and see it visually and really kind of pull both of those things together.
Nice.
Yeah, I'd add to that, PTC has one of the most vibrant blogging communities out there. Part of it is under the ThingWorks banner. A lot of it is under the kind of old-named Product Development Report. But I'd encourage people as they go to ptc.com to seek out the blogs. And these are written, by PTCers, by our customers, by other, third parties. But it's it's a great wealth of current insight and thinking, also available through ptc.com.
All right, guys. I'll ask you for those links, and everybody, I'll put them in the show analysis notes, so we're just one click away. With that, guys, Jason, Jeff, thank you. Lots of fun, and I think it seems like we're worshiping the same technology. So I appreciate the discussion.
Thank you, Bruce. Thanks for having us on. It's been a great conversation.
Pleasure to be with you, Bruce. Thanks so much.
Okay, that was a good talk with Jason Schern and Jeff Miller. This podcast goes vertical, deep diving into different topics each week. If you prefer a more horizontal and structured approach to learning IoT business and its orbiting technologies, check out my book IoT Inc., published by McGraw-Hill, or become a certified IoT professional by completing the ICIP training and certification program. For details, just go to www.iot-inc.com. Also go to www.iot-inc.com for an analysis of this episode, links to things that were mentioned during the episode, and very importantly, the episode's PDF transcript. Just search for the name of the episode or the guest. If you're new to this podcast, subscribe. That way you'll get every week's episode delivered straight to your device. Or, if you've been listening for a while, there are 3 ways you can support the show. You can leave a rating or a review on iTunes. Just go to iot-inc.com/iTunes. It only takes 1 click to leave a rating, a little bit longer to leave a review. You can share it on social. I'm on LinkedIn, to a lesser extent on Twitter. And of course, you can support this show by buying my book, IoT Inc., or the ICIP training and certification program. It's how I pay the bills. Next week's episode is Breaking Down and Building Up IoT's Digital Twin with Jim Tung of MathWorks. I hope you can join me then. I'm your host, Bruce Sinclair. Thank you for listening. Till next week, may your path to IoT business be a closely simulated one.
You have been listening to the IoT Inc. Business Show.